Hello and welcome to another code along. My name is Alexander Hansal with the Siebel Hub and Black Sheep IT Consulting. And today we're going to code along a retro feature. And that feature is visible here on the screen at the very bottom of the list applet here in Siebel Tools. So Siebel Tools was conceived probably more than 25 years ago in the mid-90s as a Windows application, and it ever since has been a Windows application. And the Siebel Windows applications, so in Siebel 2000 there was still a Siebel client, not a web client, mind you, a Siebel Windows client that looked very similar to Siebel Tools actually. And if you take some time, you will find some retro screenshots. And the feature we're talking about here is the Alpha tab bar. So here in Siebel Tools, it's still present. So you have this nice 26, 27 buttons on the bottom of any list applet, and you can just, well, easy enough to understand, click any of these buttons and filter, in this case, the name column by anything that starts with the letter D or with the respective letter. And there's a button to, well, unset the filter and show everything. So this alpha bar is very handy, of course, if you want to, well, do a quick filtering in the name field. It's kind of hard-coded or soft-coded to the name field. And how does this work? And does it still work in Siebel applications? So the answer to the second question, that's a spoiler alert here, is no. Out of the box, this is no longer available. It has been deprecated in OpenUI. But let's investigate a little bit how this works in a classic list applet in the Windows application. So if you go to any list applet, and we can just pick, well, there's a list applet right here. So if you go to the list child element, so every list applet has a list control, which in itself has the list columns. And if you look at the properties here, there's nothing much related to alpha tabs, but at least up to this version of Siebel Tools, if you go to the properties window, you find the alpha tab search field property. So this is how it was set back in the Windows days of Siebel applications. So this is no longer functional. I've tested it. But it appears to be customizable as a sort that has been customizable so that you can set the business component field to which the alpha tab search applies. But even if you set these things and deliver a workspace, the list applets will not suddenly show an alpha tab behavior. It does no longer work. It's not supported. It's deprecated. But just for a history lesson here. Another thing that you might or might not know about Siebel Tools, and that also might be something for the 100% parity if any of the folks from Oracle are listening. If you press F1 while with for example the list child element selected as the active applet, if you press F1, the Siebel Tools online help opens the object types reference document, which is also of course available in the online bookshelf, and it opens at the exact right place. It's context sensitive help. The F1 button is a classic button to open context sensitive help. Unfortunately in web tools that no longer works that way, but this gives us also the properties information, including the alpha tab, which of course now is obsolete information. That's no longer true. But just in case you're interested what all these properties mean, there's just one button click away, F1. Okay, so now let's fast forward to 2022 and have a look at the Siebel Web Application. So here I am in, well, the account list applet, and I have already implemented the code that we will walk through in this video. You don't see any difference. It's a plain standard list applet behavior. It's just in, well, this one is in show more mode. So let's go to show less, just to show, yeah, this is a perfectly normal list applet. And list applets have this inline search. So you see I've experimented with it, setting it to B, or B is just enough, and selecting maybe a column. If you don't select a column in modern Siebel versions, it still works, but the performance will deteriorate because it searches for every visible column. So yeah, selecting a column is of course a good idea, and suddenly, and this is now customization, of course this doesn't happen in standard Siebel, we get an alpha bar, and we can use it of course to, well, click the button and it filters. Okay, so that's the solution, or the minimum viable product that I implemented here, and we'll walk through the code. But you can already see that it obviously messes with the input box here. So it leverages or piggybacks upon the standard inline search. So for example, clicking M, well, does a search for anything that starts with M. Clicking the asterisk, well, does an almost empty search with anything. Let's look at the letter A, and you see at the tooltip already, when I click it, becomes obvious that this is a 21st century implementation. So you can have custom behavior. Basically, each button is fully customizable. What exactly? So here's a case insensitive search for anything that starts with uppercase or lowercase a. And you can implement, as we will see in the code, anything you like. That means you can, within the limits of the inline search, it cannot do everything. It cannot do functions, for example. But within the limits of inline search, we will be able to create any number of buttons, not just alphabetic letters of the alphabet, but any button, for example, a button which searches for a specific word or specific content of a field, and that will then apply. So yeah, so that works pretty well, and I've created a physical renderer for list applets, so it's available on any list applet right now because I've associated this renderer with the default list applet. We'll see that in a bit when we talk about the manifest, but let's see if it works, for example, on a pick applet. So here I'm picking the account, and there's just not enough space for 27 buttons, but here, now that's better. So if there's a selection already made in that pop-up query combo box, I've just double-clicked, and here is the DevPops feature, the X-ray feature kicked in, gives us the exact control name of that field. So let me close that box again and open the pop-up. So DevPops is of course something you will find on GitHub, on the Black Sheep GitHub, and there are plenty of videos on the Siebel Hub YouTube channel. So yeah, if it's already selected here, then the alpha tab shows, and of course it works on the list applet, the pop-up list applet as well, because it's a physical renderer associated to the default list applet. One registration in the manifest, and every list applet inherits that behavior. So another feature I built in that proof of concept is when you remove the column, like empty the combo box, the alpha bar goes away, discouraging users from clicking it while not having selected a column, because that will deteriorate performance. But of course your mileage might vary and your users might have different requirements. So yeah, so we have seen the history of the alpha tab, and we have seen a well, implementation in Siebel Open UI, and this is a code along, so we want to see the code for sure. So the code, if we think about how to implement this, it is a list applet specific feature. It doesn't have any meaningful solution. It's not a meaningful solution for form applets, for instance. So list applets it is, and it's physical, so it shows additional buttons on the UI. So yes, we need a physical renderer for list applet. And what better place to start than the code template generator curated by our friend Duncan Ford on GitHub as well. So you will find the link in the description. But if you have tinkered around with Siebel Open UI, you sure have come across these very handy template generators. So I picked PR, I picked desktop list applet, and I named my physical renderer alpha tab. No comments, no logging. And what I got is this template, boilerplate, physical renderer. I presume you're familiar with physical renderers in OpenUI. Physical renderers have 5 functions that you can override: init, show UI, bind data, bind events, and end life in case when the applet is decommissioned. So first we need to copy this code and create our own custom file. And I have done this, so the file's already open. And this is the final file, so there's code there that we'll talk about. So here's a Visual Studio Code with the custom file I created in the Siebel/custom folder. So this is a Siebel 22 implementation, so it starts at Siebel web root, in the AI, scripts, Siebel custom. So that's where your custom files go. And so you store it here. And then you have to register it in the manifest. So let me show you the manifest. So in case you're surprised about the sitemap here, this is the right click on the sitemap button implemented by DevPops 22. This is the psych map, as I call it. And I have recently used the manifest administration. So that's a feature of the psych map. And here's the manifest administration. And well, let me just see if the alpha bar works here, just for good measure. Yes, and so I could just search for everything started with D and getting the default list applets. Well, that's just using my own dog food here. So here, if you look at default list applet for a physical renderer, there's actually 2 of them. So the gray one, the non-editable one, is the standard vanilla non-editable seed data here, nothing to do. But if you want to override your default list applet renderer and do that very, very carefully, you have to work with a test applet first. But if you copy that entry, you get a custom entry for default list applet, applies to any list applet. Be very careful. If your code is not working, your list applets will stop working. You can always comment out the code and you'll be fine. So here I created one expressionless entry, so default entry level 1, and I have associated the file I registered in the manifest files. So Siebel/custom/alpha tab pr.js. So for good measure, this is also first has to be created in the manifest files. So let's try and find it. And well, there we go. Alpha tab pr.js is registered here. Okay, if you're familiar, and I'm presuming that you are, when you make any changes to the manifest, you have to, well, log out and log in of your session, and then you will be able to see the changes. And of course, we have to implement code. Now let's look at the implementation again. So we have something that listens for events on the standard control for the combo box here. So if I select the value in the combo box, could be any value, like the where column, then the alpha tab is displayed, only then. So I have a kind of trigger to display or to hide and show the alpha tab. And the alpha tab consists of a list of buttons. And we can take a look, we can inspect those buttons. And yeah, it's a diff. Notice that it's relative to the applet, so there could be more than one list applet in the same view. And it has buttons, well, one button for A and one for B and one for C, so there's like 27 buttons here. So these buttons are not declared in the repository, they have to create it on the fly by JavaScript. And that button bar is the physicality, so it's something we want to add to the user interface. So let's start with that, well, with those event listeners. And also with the button bar. So here we are in the physical renderer code that we generated with the PMPR generator. And we have done nothing in the init function, nothing here. But in show UI, I have, well, very carefully, because this is default list applet, so we're really not taking any chances, put it in a try block. And there's a function I call in show UI, create alpha bar. So I created a custom prototype function to call, avoiding code clutter in the show UI. So show UI is very readable. The only thing we do is we try to call this function, and if anything goes wrong, we show an error in the console. And bind data is nothing here. Bind events, yes, we are binding some events. So bind events is good to, well, call a function. Again, I like to keep things clean. Bind alpha tab events here. And again, we try to call this function, not taking any chances, not to really, well, ruin our list applets when there's any error in the code. The code will just halt and cause trouble. So here's the bind alpha tab event. So that's the first thing that, well, show UI happens, and we'll take a look, but we talked about the combo boxes. Now, these are full-grown controls in every list applet, so we can grab the control element. So if you want to establish a listener, let's say on this combo box, you would have to, well, identify the element, like I can do with inspect, so it's an input. And I notice it's an autocomplete input, autocomplete jQuery. Here there's a class that gives it away, autocomplete input. So jQuery is running the show with all the combo boxes in standard Siebel. Also the object type, because the recording is enabled, JCombo box is here. And well, I have devpops, so I can run the show controls, X-ray, and I get, well, there's no label, but if I hover over, I see it's the control called query combo box. And the input box next to it is called query srch spec, query search spec. And the button is called pop-up query execute, and executes the find method, which is important to know. So we need to work with all these three controls. And the controls are part of the presentation model's control set, which we can get. But there's a twist here. So let me open up the pop-up list applet. We want this to work on any list applet, including pop-ups. And here I can double-click to run the X-ray. Again, the X-ray is a devpops feature. And there's a slight disappointment here because the combo box control is called pop-up query combo box with slightly different spelling than in the non-pop-up list applets. And also the text box is called pop-up query search spec. Okay, so we need to take that into account when we search for controls. So the search for controls, so the first code in the custom bind alpha tab events function is actually getting the PM. We are inside a PR, so with this get PM we get the presentation model instance. And the first thing I do is use it to get the full ID of the applet. We want our code to stay within the boundaries of the applet. So not, and also all our elements that we want to create, we want them to be relevant or respective to the applet, so not be ambiguous. If you have more than one list applet in the view, you have to stay within the applet. So getting the full ID in a variable here is what we do. And the third line of code that we actually look at is calling another custom function, get inline query controls. Now let's go there. So get inline query controls is a helper function. It's part of the PR prototype now, so I can get the PM if I need it, and of course I need it. I have an empty object here, the control object, and I have the control set. So here, this is what we just talked about, getting the control set, get controls, calling the get controls property from the presentation model. That's a standard Open UI line, and you see it very often. So now in the control set, there are all the controls for each applet, and of course also the combo box, the search spec, and the button. And we have to distinguish pop-up applets, so we do another PM get. And is pop-up is a nice property, tells us true for pop-up applets or false for non-pop-up applets. So here, quite hard-coded, could be made a little bit more flexible, but it's good enough for prototype. So here we populate the control object QCB, query combo box element, with the one control that represents the combo box and another one that represents the search spec input. So the two fields, the combo box for the columns and the input box for the search spec. And else, that means it's not a pop-up applet. We have the different naming here. The button is named the same, so I just put it outside the if-else block. So the CO object that's returned is containing all the three relevant elements that we want to deal with. Okay, so let's get back here. So now we can grab from the control object, we can grab the query combo box, and there's a variable reserved here, query combo box element. And now we do just a quick sanity check if we have a query combo box. So if it's not undefined, then we can grab the DOM element. And this uses the getUI wrapper function. It's part of the physical renderer. You have to pass in a control object. So we have the query combo box control. So we get the wrapper for that control. And we get the element, the famous getEl function. Get the DOM, or actually jQuery element, returns the jQuery representation of the very DOM element. And now we have the element and we can work our magic. Magic, that means adding, well, not one, but two event handlers on it. The first event handler is autocomplete select. Now we know that autocomplete, jQuery autocomplete is applied on the dropdown. And so we can work with the autocomplete event handlers. So let's dive a little bit into jQuery autocomplete. So easy to look up on Google. And there's the API documentation. And the documentation allows us to see all the exposed events for the autocomplete widget. And we want to catch the select event. So here's when the user makes a selection. And here we see that we can, bind an event listener using on autocomplete select and then defining a function which receives the event object and UI object. And of course, we have to put our code in here. So here we check the UI.value, that's the UI element's value. If that's not empty, then we show the alpha bar. Now the alpha bar has a, it has to be unique to the list applet. So I use the ID hash BCRM, Black Sheep CRM. So your customization prefix, alpha bar underscore, followed by the identifier of the applet. So later when we generate the custom DOM elements for the alpha bar, we have of course to generate it with the exact ID. And we simply show that. So we generate it and it's hidden. It's already there, but it's hidden, so we just show it. And on keyUp, keyUp is a regular jQuery event handler or JavaScript event handler. On keyUp, we just watch out if the value goes empty. So that is the user deletes the column, and then we hide the alpha bar. So that's the two event handlers that are registered by this custom physical renderer as part of the bind events function, so in the correct place. And we use a helper function to get the relevant controls that we want to work with. We focus on the inline query controls here. So let's watch this one more time. So the alpha bar itself. Here we see the wrapper diff for the button bar, and the ID is indeed BCRM, A bar, and S_A1 is this applet's full ID. So this is how we can make stuff unique. So if we address multiple list applets, we always have to work with the full ID. Okay, now the alpha bar is visible already, but how do we generate it? That's in the create alpha bar function. Remember, we call this function in show UI. And the first thing we do, not surprising, we call our helper function to get the inline query controls, these three controls that make up the inline query. And now we have it for later. And in this implementation of alpha bar, I already demonstrated that you can have, well, any number of buttons. It doesn't have to be the alphabet buttons, but of course that's a nice retro example. And you could have any label on the button. And for simplicity, I created an object called a bar, and each element in the object or property, the first part of the property is the label on the button. So button with label A, and the actual the actual query that is then inserted into the input box, A asterisk. And that's pretty self-explaining what I do here. So create those 26 buttons. There's no better way to do that. And there's the asterisk button. And you can override it. So you can imagine a getter-setter function, which I haven't implemented, but I leave that to you, to allow even users using some options dialog or administrators specifying some separate buttons, so you can read them from the client PM properties in the repository. But here I just demonstrate overriding the A button with A asterisk or lowercase a asterisk. So that's the insensitive, case insensitive query. So that imagine that coming from somewhere else, from a customization of the custom code, so to speak, allowing, for example, a user to have very much like saved queries, custom buttons they like. You get the idea. So if you have, for example, language specific stuff like the umlaut in German, you can create those buttons as well. If you want a button that is labeled contains black, you can create it with asterisk black asterisk as the value, and so forth. So that's the point here with this, well, a long set of a lot of lines of code, but I'm not paid by lines of code, so that's okay. Yeah, so that's the alpha bar definition. Now we do the needful, so to speak. We get the PM instance, we get the PR as a variable needed later, we get the full ID of the applet, and we grab the query combo box and the query search spec. And there's the query combo box element for later and AB for later. And here's the main container, the alpha bar containers. This is where I construct the wrapper diff using jQuery with the full ID. Again, the full ID is very, very important. If you create anything, custom DOM elements inside an applet, always make them specific to the applet using the full ID or the applet ID or the placeholder. It's up to you, but make it unique. Make it unambiguous. So when you address this, you stay inside the applet. I've been lazy, I admit. I've not created a custom style sheet, but I want some style. Well, here I resort to the CSS jQuery function. I could easily transfer this into a style sheet later. So a bit of padding and display none. So the alpha bar is not displayed initially. Okay, sanity check. Do we have query combo box on the applet at all? If not, nothing happens. But if we have, then of course we want to grab the element, the DOM elements for the query combo box and the query search spec. And now here's the generator for the button bar. So here we iterate the A bar variable. So those 27 definitions or more or less. And for each definition, we create a button element with a unique ID. The ID is unique to the applet and to the element, and the property name is just a label for the button. So again, this is a very low-level code or highly simplistic proof of concept code. You could do better than that, probably. And you see that we also generate a title, which is the tooltip, displayed as a tooltip by the browser, and we add some lazy CSS to each individual button. Again, this should be in a style sheet, and I've been too lazy to implement a style sheet, focusing on the JavaScript portion here. And of course, these are just, at this point, is just buttons, and when you click them, nothing happens. So for each button, we have to define a click event handler. So we use jQuery all over the place here. So the event handler for click. And of course, we have to, well, fill in the query search spec and press the button. But you might have noticed that there's also some formatting going on. Let me just reload that view quickly and select the name column. So I see the button bar. So if I press a specific button, it's highlighted. So there's some, well, very simple CSS styling. And obviously, if I press another button, no button is highlighted except the one I clicked. So the very simplistic solution to that is first find the parent of the button. So that's the diff container, and find any button. There might be more clever ways to do that, but it works. And just release more or less or unset the font weight and the background, which is the stuff that is applied to the formatting. So any button goes back to standard button look and feel. And now we grab the value. So the value is actually so for the value, we use the text of the button. So basically, this reads, if you press the button with A, this translates into the uppercase letter A, which is the property name, so to speak. So that's what the button displays, but we want actually this. So we look it up. It's basically a lookup function in the A bar variable. We look up the value of the button with the letter A. So this translates into the current value, like A asterisk or lowercase a asterisk or whatever. So this is now in V. And we can use the UI wrapper for the query search spec, the input box, and call the set value method and just set the value to v. So this is how this value is populated. So the user also actually sees it, which is good. The user sees which column is selected and which value is used for the search spec. And now we have to press the find button. And there's an issue I had here. To be honest, I invoke the method that the button invokes. So this is how you do it. You call the PM execute method, invoke method. There's a method called invoke method, and you pass in the name of the method you want to invoke on the applet. And find is the method behind that button in the inline search. Note that it's not execute query or other. And for some reason, I had to call it twice to succeed. So this is stupid code here, and must be another solution. But it's a proof of concept. So calling the community here. Do you have any better idea? I have a better idea too, which is like make it a real query on the applet. But that's not the point here. It's a proof of concept. We want to use the inline search of the list applet. We could, of course, well, run a query, and the IdeaPort Riga Nexus bridge has a very cool function to actually call a query on the applet with the name of a control and the search spec. So we could translate everything into a real applet query, but that's more effort than is actually legit here in this code along. Maybe in another code along. So, and then we just style the button we just click with this bold font and light blue background, so it's visible that the button is active, or more or less so has been clicked. So all this code here is the loop creating those buttons, and at the end of the loop, still inside the loop, we append the new button to the alpha bar container. So at the end of the loop, which is here, we have the alpha bar container fully populated, and now we can show it. So we append it to somewhere, and you notice I appended it to, let's go back, well, just below the inline search, which is reasonable because it's a very long button bar, and even on smaller applets it has to break, but that's not the point here. So you have to position it somewhere. So in case of pop-up, again, pop-up applets are a little bit different, so we have to take care of that. So here the QCB container, so that's the container element where we append our new alpha bar to, is actually the parent of the parent, and we append it there. And in a regular list applet non-pop-up, it's just the parent. So that's the only difference here. And we append it after, or we add it after and don't append it. So slightly different handling of pop-up applets is demonstrated here. You could go and place it somewhere else. For example, at the end of the bottom of the list, like this commented lines explain, well, you could just find the applet element and append the alpha bar, and it will be on the bottom of the list applet, like in the retro look and feel of Siebel tools, if you want that. But I guess it's a better look and feel if it's in line with the inline query, if you will. And in case there's already a value selected, like in pop-up list applets for the column, we have a timeout here of 100 milliseconds later, because that's the amount of time needed to fully open the pop-up applets and actually be able to read a value from that combo box. And if that value is not empty, we just show the alpha bar, as is the behavior on the pop-up list applet. Okay, and that's all the code you need. Well, it's quite a lot of code, but it's let's wrap it up again. So we have a create alpha bar function in show UI that renders the custom DOM elements. That's the alpha buttons, and inside a container, hidden by default. And we have in bind events, we call the bind alpha tab events, which make sure that, well, we have the necessary events in place on standard elements in this case to show and hide the alpha bar. And the alpha bar clicks are handled inside the alpha bar. And we have a helper function here for getting the inline query controls. So that is the 3 controls that make up the inline query feature in a list applet. Okay, and when this all comes together, we can run it through, let's say, the debugger. So I have the file open in the Chrome Developer Tools already. So the first show UI should be the first to be executed. So let's just place a bit of breakpoints here. Let's just reload the view and see how it works in the code. Yes, show UI comes first, calls the create alpha bar function. So let's jump right into that function, F11. So now we get the inline query controls. Let's just jump over and we just verify. Yeah, we have 3 controls, QCB, the combo box, the execute button, and the search spec. And now we define the A bar variable, override it, and A bar now is this object. As you can see, A is overridden. Imagine that being maybe a separate functionality you can implement. Now we get all these variables that we need, the PM, the full ID. Here we have that full ID grabbed. And we create the main container, apply the CSS, and now we get the elements. So these elements returned by the getEl are jQuery instances. So you can also see the browser lets you hover and identify the element. So that's the combo box. And the other one, is the input box or the search spec. So now that's the iteration for each. Let's watch for the first button. So we generate a button element. So AB, that's a new button. And that's the first A, the first in the definition. And we add the attribute and the CSS, and we define the click event handler. Now in the click event handler, place another breakpoint for later. And now we append to the A bar, and there are 26 more to go. So let's just jump right here. And now that's not a pop-up here. So we jump to the else and we get the QCB container. So you see that's the container, the standard container element containing the inline search stuff, and we append it after. Or we don't append it, we place it after, sorry. And now it's already there, it's in the DOM. At that point in time, it's in the DOM, but it's not visible because display none. But we should be able to go there, or in the elements, find BCRM A bar. Oh, sorry, that's the styles. Sorry, have to search on top here. BCRM A bar, yeah. So that's the proof. It's already here, but it's display none. So if you at this point, if you uncheck display none, well, there it is. So we have successfully inserted it in the. We're still in show UI, so there's no data, but the button bar is there, just not visible. Okay, and there's our set timeout. In case the QCB element has a value, we actually call show, so this would display it, but that's not happening. So we're going very slow through this physical renderer. So now time for bind events. So let's briefly jump into the function, step through. So we get the inline query controls again, and now we get the combo box element. Again, that's the first element in the inline query. And yeah, we attach to the autocomplete select and key up event handlers, which simply call show or hide on the alpha bar. So nothing spectacular here, so let's just jump right over. And now finally the OpenUI framework was, well, patient enough, gave us time to inspect that code execution. Now, of course, we want to see the button bar and see what happens when we click. So now the button bar is displayed, and let's just click letter K, and we have a breakpoint in the click event handler. So the first thing we do is remove the formatting. Okay, so it's already done. Remove the formatting from every button, and now we get the values. Let's see, that should be K asterisk, right? Because we read it from the A bar definition. So A bar is like a global definition of a toolbar allowing you to do any number of predefined queries, really. So that's what it is. Now we have the PR, get UI wrapper, setting the value. So now you see the value appears in the search spec, and now the find method is executed. You see the first find actually is kind of emptying it. I have no idea why. So here I call a blank, and the second find actually does it. So again, any help from the community, much appreciated here, how to make this more intelligent. Okay, so then the CSS is applied, so the button becomes more prominent. Okay, so that's what happens at the click. And that's it. That's the walkthrough, our code along on a retro style alpha tab bar, which is very versatile, as you can see. And since it's a physical renderer for list applets, you can apply it to a single or one or more list applets of your choice, or you can apply it to all the list applets. Be careful with that. All the list applets, including pop-up list applets. So let's just see if it works on an address field, for example, address MVG. Let's ignore the breakpoints for now. And yep, it works on address, on the associate applet. Wherever there is an inline query control, we now have the alpha bar. Let's just press a button, and well, it works on the street address. Of course, it would work on the city field. Yeah, like a charm. And we can select an address that we find and select it. Okay. So just demonstrating that it works on any list applet. So with the last glimpse at the code, and check out the description of the video for all the links you might need to GitHub and to the Siebel Hub, and where you can learn more with the Siebel Hub on OpenUI. Yeah, feel free to check all these links out. Thank you very much for watching. My name is Alexander Hansal. Take care and bye-bye.